Thanks. So I'm going to give some background on where this project started. So Colaboratory began primarily as a Google internal project where we had the goal of having Ipython and Google Docs together, so that you could have a Google Docs-like experience, but with Ipython. And that's pretty much how it worked out. So we built this product, and in the end we ended up involving some other non-Google developers, such as Matthew Turk. But we built this project that would allow people to have a shared document. We never really thought in this project very much about sharing kernels, but we created a system where you could have a single document that was backed by Google's real-time API, the same API that powers Google Docs. And so two people could be editing the same document at once. People could see where other people were in the document, and people could comment on documents. And this is what it looks like. So as you can see, you can have comments. Two people can edit it at the same time, just like Google Docs. And you have these icons to show where people are in the document. So we thought this was pretty cool. It's a really nice experience. You can share a document with one click. So we're pretty happy with this. But we didn't think it was really a very viable external strategy to have a product that was a kind of a rewrite of the Ipython front end. So we talked to the Ipython and Jupyter developers, and we came up with a plan. And the plan was to have this kind of possibility built into Ipython itself, built into Jupyter Notebook. So Jupyter Notebook will always remain agnostic to the back end. It will not be tied to Google Drive's back end. But we're building into it support for different kinds of storage of the document. So there's, of course, the current static storage document, the static way to store the document as files. We've built already a way to store files on Google Drive instead of on the local disk. But the next stage is to do what we've done in Colaboratory inside Jupyter Notebook. And what that means is to be able to have Jupyter Notebook natively support real-time interaction between different people editing the same document. In order to do this, we also want to do it in a way which is agnostic for the backend. So the backend might be Google servers, but it might be also a local server, the same server that's handling the kernels. And Jupyter Drive is the project in which we're doing this for the Google backend. So because there are lots of different approaches that we could use to do this, we have two basic architectures that we have in mind when we're thinking about this. So the first one is the current system, where the files that are served up that you're able to use are exactly the same, done by exactly the same server as the server that's serving the Ipython notebook, the server that's serving the kernels. With the Google Drive-backed version, we would be talking from the client side directly to Google APIs. So we call that a client-side implementation, even though there are, of course, servers involved, the Google API servers. And if we go back to the server sides, you can also imagine a real-time collaboration where the server was mediating that collaboration. And this is, of course, very important for companies that don't want to be using external servers, or for whatever other reason, they need to have it all local. So what we've done so far is done the refactoring necessary so that we can support this alternate backend for file storage, not for real-time collaboration, but just to store documents on Google Drive. So this is the current project, Jupyter Drive on GitHub as part of the Jupyter project. So we've separated out the API within Ipython for storing files, and then we've provided a Google Drive-based plugin to be able to do that, to be able to store files with Google Drive. So that's what we've done so far, and now Matthias is going to talk about what we're going to be doing next.
So hi everyone. So Kester already showed you what has been done so far in the previous year. I officially joined the Ipython team last November, and I've been working on basically integrating step by step Google Drive into Ipython notebook so that you can open your notebook directly in Ipython from directly access your Google Drive document. So there is many things that we want to do in the future, and I will try to explain you why and what are the challenges that we encounter to do that. So first, we need to take a step back and try to understand what is actually collaboration and what people want to do. It's something which is not obvious. It's generally just, I want to share this document, and I want other people to be able to write into it. But because we have running kernels and everything, you need to actually know what you want to do. The first thing that we saw with the Ipython notebook is something that I guess most of you have had on once, at least, is you open a notebook, you do thing, you forget your notebook is open, you open the same file, and you do other thing, and then you change in one thing, you save, and basically you get, like in many other applications, two documents that have different state in your applications but are trying to write on the same file on disk. And this is collaboration. This is collaboration with yourself. For most applications, it's pretty easier to do when it's local applications because you are on the system, but because you are using a web browser, we don't always know that there is another window open, and the other window can be on another computer. This is basically minimal things about collaboration. And most of the time when our users so that they are angry, and often I am angry with myself because I know why it's like that, and I'm trying to fix that. So first, why we decided to use Google Drive? First, because it works, and we don't want to reinvent everything. I have support from Kester most of the time, which is helpful, and I have some insider knowledge, which is really, really nice. You also have built-in credentials, so we don't have to reinvent how people log in. And so basically, I don't want to reinvent the wheel for now, but as Kester said, we are trying to do things in a way which is pluggable. So right now, everything you have right now, and we will have in the future, will be with Google Drive, but we are building that in a way which is agnostic of the backend. And up until now, it was really great because when I arrived in November, I was able to build purely an Ipython extensions that was able to make the storage backend Google Drive without changing the internal of Ipython itself. It's even really well designed because I was even able to create like a mount point for the backend where one content manager, we call it, is able to both see files from your local hard drive and from Google Drive. But we never really took into account that we want real-time collaboration in documents, so it just works for loading files, so you don't have many users that edits for now, and that's what we are trying to move forward with. So Kester showed Collaboratory last year at this same conference, and when they built it with Kayer and the other people of the team, they didn't really take into account the sharing of the kernel. And here I will show you this is how Collaboratory works by default. You basically have two people collaborating. So here it's me on one side and Fernando on the other. We share the documents through Google Drive, and we each have our server, which is a black box, and the kernels, which can be Python, Ruby, or Haskell. And I will write something like a equal 1, and then ask the value of a, and then see that a is 1, and this gets things to Fernando. And Fernando come back later and say, yeah, awesome, a is 1, let's look at what a plus 1 is, and name error, which seems obvious because the kernels are separated, and then I see that. And then you get inconsistency between the document states, which basically is what normal sharing is. But here, because you're programming, you have a namespace which is on the kernel of each machine. And basically, I have a equal 1 because I executed a equal 1, and Fernando's namespace in his kernels is just nothing. And then I'm unhappy, and he's unhappy too. This is not obvious to, you can just say, hey, why don't you just serialize the data and move things around? I guess most of you might work with data which are gigabytes or even terabytes or even more. You probably don't want your network connection on every key press to sync a terabyte of data. So yeah, so this was a contrived example, but you can get similar annoyance if someone load a file or restart its kernels or or something like that. Even in more subtle case like scikit-learn, which will do cross-validation, train and split. I don't see anything here. If both of us run that, I don't see why we should get different results after. But probably under the hood is doing some random things, and after, if we do analysis, we will see something different, and that's really not something you want to do. So I don't believe that having each of us a kernel on their machine is really useful. Maybe it's useful because I'm really bad at English, because I'm French, and all know that French are bad at English. So when I work with Thomas, it's really nice to have Thomas correcting me or all my English mistakes everywhere. But in most cases, you don't want to have a kernel on each machine. So the idea is, let's share a kernel. Then when I type a equals 1, it syncs to Thomas. And when Thomas check which is the value of a, it's just the same kernels, so it's the same namespace, and it works. But you know, I don't really trust him. He might ask the JavaScript to display my email login credential, and I don't really want my password to be shown on everybody's page. So sharing a kernel is also a security issue on the front-end side. And you all know that security is really tough on kernel side. So one of the ideas is to also isolate everything, but usually scientists don't like to be isolated because they don't want to copy a terabyte of data in and out of containers. So here is an architecture where you basically isolate the kernels, but each of us have a server, and so the server can act. I can send things on the kernels that ensure the kernel who is actually running the code. So you might be able to know who is doing what and only display when Thomas the JavaScript show email credential, only show it to its user credential and everything. But it's still not perfect, and that's something which is, again, tough, is that if each of us disconnect and we have a long-running computation, then when the results come back from the kernels, the computation doesn't get appended into the document. It's something that you might already have seen if kernel output is lost when clients disconnect. So I guess you already have seen that. You close your browser, you open it again later, you had the computation running, and basically you just see a star in the cell you are running, and it never gets in. So it's not either really a solution, and we don't want to completely isolate kernels, but it's still something that might be useful. So right until now, the thing we want to do is basically get a concept of a project. When you want to work on something with someone, with a group of persons, you want to share a folder. And this folder, you basically will use Unix privileges for people to be able to read and write things with the right permissions. But because we have executions, because we have a kernel that need to run as a specific user, you don't want the kernel to run as one of the user of the project. You want the kernel to have your own user. You need to create users for the kernel to start. And basically, that is what SageMath Cloud does right now. But it has some drawbacks. We need the ability to create, manage Unix user, which usually in lab IT people are not really happy with, because you need to be root. And it gives also some slight weird bugs, like if you go into an Ipython kernel and you write bang, who am I, you will see that you are the Unix user for the kernel, so you will see I am kernel. And if you go into the notebook page and you click on new terminals and you type who am I, the kernel is actually, the terminal is started on the server side, so you will see your own username. And that's something which is really tricky because you might think you're doing exactly the same thing in a terminal, in the notebook application, and in the kernel, but actually you are not, which might lead to really some subtle bugs and annoyance. And also the model where we have the kernels, which is isolated, still don't really fix the issue on the client side where you can inject JavaScript or steal people credentials. And we all have seen what the problem are with security on the internet. And the last thing, because we are scientists, we really do care of who is doing what in a computation. And if you share a kernel, and if you touch a file, or if you run a computation, if you share a kernel, you still lose the ability to know exactly, especially in Python, because Python is really dynamic, who did what at what point. Like if I wrote a function and you call the function later and the function does something wrong, did you actually did something wrong and erase the hard drive, or was I the one to be bad? So right now there is not a single solution that fits everyone. We are working on that. Languages were never actually designed to make this kind of usage of real-time collaboration in mind. And right now, we are in the progress of really refactoring and rewriting the whole notebook almost from scratch with the help of many people to give you the ability to be at several people on one notebook typing at the same time and see what others are doing. But as usual, you know us, we do things the right way, so which means that we are slow. So we are sorry there is not real collaboration yet, but it's in progress, and we hope to bring that to you soon. Thank you.
Thank you. We have time for a few questions. Who wants to start?
When is it going to support Python 3?
It's already support Python 3. I don't have a Python 2 kernel.
Okay. So it was 2.7 the last I checked. Maybe
More questions?
I will add one thing, which is because we are language agnostic, this will work regardless of the kernel you run. You might need to run the server using Python 3. You will probably at some point have to run Jupyter only on Python 3, but you can have your kernel which is Python 2 or Erlang or Go or Bash. And because of the architecture of Jupyter, the implementation details of which language does a real-time collaboration and the server is not relevant.
I have one more question here. Do you plan to make it open source, and which parts will be open source and which part will be internal to Google?
So everything Matthias has spoken about is open source. We have an open source version of Collaboratory. It's not clear if there'll be more updates to that.
Cool. Let's thank the speaker again.